Now, after that, if you have any, uh, what should I say? If you have any doubt, any questions, etc., you may contact me. We can arrange one more class afterwards. The notes have already been sent to you. I think all of you have received the class notes on
Yes, sir.
this chapter. So let us straight away go to the presentation mode. So this is the chapter on high voltage cable, and at the beginning of the cable, some points have been discussed on insulating materials, and then there is a cross-sectional view of a single core cable, which actually shows how the insulating materials are wrapped over the conductor. So I think these things, that is the layout of cross-sectional view or layout of a single core cable, placement of insulating materials over the conductor and other things, I think these things have already been discussed. Okay, so
Yes, sir.
I will not discuss all these things because all these things are already known to you. Similarly, uh, what is the purpose of sheath, how sheath works actually, these things also, I think you already know, and these things have already been discussed. What is the purpose of providing sheath over the insulating materials, etc.? What are the materials of sheath? I think these things have also been discussed. What do you say?
Yes, sir.
Yeah, yes, sir. In underground
These
cables.
are
Yes.
basically recapitulations of what you have already studied. Uh, so we are not discussing all these things. Just have a quick go through these particular points, and you will be able to brush up the things which you have already studied. That way, next to sheath, armoring is discussed. Armoring is something which very important in connection with the cables. And with these preliminaries, next what is considered is the three-core belted cables. Three-core cables, which are also called belted cables. Now, these three-core cables are mostly paper insulated. Oil impregnated paper is wrapped over the three cores of the insulation. I mean, three cores of the conductors. Uh, Now, this particular, so far as this high voltage engineering is concerned, this particular type of cable, three core belted cables or paper insulated cables, they suffer from a particular limitation that these cables cannot be used beyond 22 kV. Now, why these cables cannot be used beyond 22 cable, that is of our interest, and that is discussed in the next slide. You see, the belted cables are usually used up to 22 kV. Now, belted cable has one disadvantage that as the field develops inside the cable, actually three conductors are there which are connected to three phase voltages. As a result, the electric field which is developed inside the core, I mean inside the cable, that is rotational in nature. So rotating electric field is develops there, and a tangential stress along the surface of the cable of the insulation should be along the surface of the core of the insulation, that is on the paper, is developed. So due to rotational electric field, tangential stress develops on the paper, and the paper has it has been found that paper cannot withstand high tangential stress, and that is why these cables, it has been found that if used beyond 22 kV, the magnitude of the rotational field or rotating field and resulting tangential stress is so much that it leads to failure of such types of cables. That is why these three-core belted cables are not used beyond 22 kV. That is the point of interest so far as high voltage engineering is concerned. Next, there are H-type, HSL type, different types of cables. I think most of these types have already been discussed, and these are the mostly descriptive things are there: H-type, HSL type, etc. Have you studied all these types? H-type, HSL type, etc.
I think no, sir.
No.
No, sir.
In that case,
I couldn't remember.
you do not remember. So, what will be our approach? These are basically, for example, SL type cable or H type cable, if we consider H type of cable. You see, the elimination of tangential stress can be accomplished by screening each core separately so that cable becomes in effect three separate single core cables laid up within the same preventing protective covering. Is the point clear? In the case of belted cables, since all the three cores of the conductors were wrapped up by paper insulation, as a result, the developed electric field, which is rotating in nature, and associated tangential stress on the paper surface led to damage of the paper insulation. But in the case of H-type cable, what is done is each core of the conductor is separately screened so that basically it becomes three single core cables which are housed inside the same protective cover. Now, in this case, what really happens in the H-type cable invented by this Oyster consists of three paper insulated cores, and over insulation of each is wounded, perforated, moralized paper, not moralized. It should be, there is a printing mistake. It should be metallized paper. A perforated aluminum foil or copper tape is used to maintain the homogeneity between the outside impregnated paper and inside paper. By the use of metallic screen, which is maintained at earth potential, electric field is made radial. Do you understand this point or not? The last sentence, by the use of metallic screen, which is maintained at earth potential, electric field
Yes,
is
sir.
made radial. So the possibility of development of uh, what should I say, rotating electric field is thus avoided. And this is the cross-sectional view of H-type cable.
Sir,
Now, yes,
sir, for HVDC transmission, we are using the ACS, sir. ACS, sir, and with a filler material inside it. So why we using the three-core material, a
where?
three-core transmission line?
Now, in HVDC is separate thing. Here, question of phases does not arise. But here, if you have to transmit power or distribute power, obviously three-phase power is transmitted or distributed. If you look at your household supply, the main meter, the cable which is used to gives supply or brings supply to the main meter of your premises, it consists of three cores. Maybe in your home, the supply is given from a particular single phase, but always the supply is drawn or supply is taken to different premises using three core cables, because otherwise it will not be possible to distribute the loads in a balanced manner over the three phases. Maybe
Sir,
in your, yes, so the
sir,
supply will be of three phase in nature. So here you cannot use single core ACSR cables.
sir, we can use three single core ACSR cable. Uh,
No, in that case the cost will be much more. If you go for ACSR cable, aluminum conductor steel reinforced, always the cost will not be within permissible limit. And also you see where ACSR cables are used. Aluminum conductor, steel reinforced, all these things, if you place mostly in cities or towns, the cables are used in underground system. As cables are mostly placed below the ground. Now, if you use steel there, there is high chance of rusting and the steel may get damaged. But here we are not using steel, but instead lead, aluminium, etc., which do not get damaged even if they come in contact with earth. So these are the criteria which restrict the use of ACSR in underground usage. Anything else?
no, sir.
Now these are the two more improved versions of H-type cable. One is SL-type cable and the other is HSL-type cables. You just have a look, go through it, the slide. So SL-type and HSL-type, do you have any question?
No, sir.
Then, then the stress in cable. I think this part has also been discussed. How the stresses in cable varies, develops, etc., etc.
Yes, sir.
These things I think have already been discussed. The stress is
Yes,
highest
sir.
at the conductor surface and then it decreases gradually as you move away from the conductor. So these things and the optimum dimensions.
Yes, sir.
Okay. So this is also next is grading of cable, capacitance grading and intersheath grading. I think you have already studied.
Yes, sir.
Okay. Now, in the class note, you will see a lot of problems have been worked out. So I'll request you to see those problems and work out similar type of problems. Limitations of grading, I think these things have been discussed.
Yes, sir.
Now, these things I shall tell you to go through. All are available in your class notes. Requirements of EHV cables. So here basically two different types of cables have been discussed. One is polyethylene type of cable, and then cross-linked polyethylene type of cable. Thereafter, some special type of EHV cables, or special type of cables which are used in EHV systems. For example, pressurized gas field cables, pressurized oil filled gas field cables. All these things have been discussed in the subsequent chapter. But these things are mostly descriptive in nature. Therefore, I am not discussing all these things. This is the diagram of EHV cable, and this is another diagram of oil filled cables, which is used beyond 100 kV. So all these things are there. And this is the special cable for extra high voltage ratings above 100 kV. And there comes your oil filled cables. Next is pipe type oil filled cables. All these things are there. Pipe type oil filled cables. And then gas comes your gas filled cables. And gas filled cables can also be of two types: gas compression oil filled cables or external pressure cable, and gas filled oil filled cables. So these things are there. These are mostly descriptive things, and here also you have compressed gas filled gas insulated cables, which is at present very popularly used. Gas insulated cables, and then your solid material cable. Under this category, polyethylene and cross-linked polyethylene cables actually comes. Now the thing is this: all these things I am not going to discuss today. Instead, we shall discuss the cable breakdown, how a cable may break down. For these extra high voltage type of cables, I'll request you go through yourselves. And if you have any doubt, any question, just feel free to contact me. We shall arrange another class to discuss or to clear all such doubts. Okay?
Yes, sir.
Yes, sir.
Okay. Now cable breakdown. Now here it has been found that actually, if we consider for simplicity a single core cable, now over the conductor, number of layers of insulating materials will be there. Now these cables often undergo different types of load cycles. That is, sometimes the load will be much more in the cable, say in during a particular time of the day when the load is maximum. Majority current, a maximum current is flowing to the core, and obviously when the current is maximum, the heat developed inside the core will also be maximum. Now after some time, the current or the load through the cable will reduce, because load is not constant at its maximum value all throughout the day. Sometimes it reaches its peak values, remains constant at the peak value for some time, but after that or before that, loads will be less than its peak value. Therefore, the contraction, expansion of the insulating material placed over the conductor core due to heat generation will be maximum when the load is maximum. But when the load reduces, what really will happen? The insulating material will try to contract. But the insulating material and the outer sheath, they not expand and contact in the same way. It may so happen that the insulating material contracts more than that of the lead or outside cover. If that happens, then within the insulating material, a void will be formed because of non-uniform contraction of the insulating material and the sheath material or covering material. So thus, in this way, a void is formed inside the cable, which has been discussed in this slide. We just go through these 2 points quickly. Is that okay?
Yes, sir.
Then what happens if the void is formed? The voids surrounded by dielectrics have much higher strength. Actually, this sentence is not properly constructed. I shall correct it. What really it means is this: within the insulating material, there is a void. Now, the relative permittivity of the void is 1, but the relative permittivity of the insulating material is more than 1, maybe 2, 2.5, 2.3, like this. Therefore, for the same applied voltage, the magnitude of the electric field uh, across the void will be much more than that in the insulating material. Is that point clear? Do you understand this point?
Yes, sir. Understood.
Yeah. Therefore, it may so happen that even at the operating voltage or working voltage level, the stress developed may not cause any damage to the solid insulating material, but it may cause ionization or breakdown of the void. And what will really happen is this: if the void breaks down, then what will happen? Actually, the void can be considered to be as a capacitance with air as dielectric medium between the electrodes. Can we think the void like this?
Yes, sir.
Now, when the void breaks down, then what really happened? The energy stored in that void is dissipated in the form of light and heat. An arc develops in the void, and the void gets short circuited with the release of stored energy in the form of light and heat. Okay. Now, if heat develops, then what really happens? It burns out some of the solid insulating materials, right? Is the point clear?
Yes, sir.
Now, if this happens repeatedly, then what will happen? The burning of the solid insulating material on either side of the void, that is the solid insulating material which are in contact with the void, will be burned, and this burning will extend in either direction slowly. Is that okay?
Yes, sir.
And finally, a time may come when this burning up of the solid insulating material may extend in such a way that it may actually short circuit the conductor core with the outer sheath. What is the result of burning up of the solid insulating material? It is nothing but the development of carbon particles inside the insulator or insulating material, I should say. And if carbon particles develop inside the insulating material, the insulating property of the material will decrease definitely, and the carbon particles will extend in either direction slowly. And when it reaches up the outer sheath and the conductor core, then there will be a short circuit and failure of the insulating material takes place. And the cable actually breaks down. We can say that. Is that okay?
Yes, sir.
Now, question is how repeated flashover or arcing takes place inside the cable. It is because actually air is a self-restoring type of insulating material. What is self-restoring type of insulating material? An insulating material which can regain its dielectric strength back when the cause for the sparkover or arcing is actually withdrawn. Now, what really happens one arc when arc occurs for the first time? There is complete ionization of the air bubble or the void, resulting in fall of voltage across the void. The voltage across the void becomes zero. Therefore, the stress immediately becomes almost negligible. And if the stress becomes negligible, the positive ions and electrons formed due to arcing or flashover, they starts they start recombining. And after some time, the void again gets its dielectric strength back. But by this time, the supply voltage is not held at its previous value, but since the operating voltage is AC, it goes on increasing, and after some time, the voltage across the bubble or the void may be such that the resulting stress may again cause another break. And in this way, repeated breakdown may occur in both the half cycles. Next diagram will explain the process. You see, this is the thing. This is the applied voltage VP, and this is the level of voltage which, when reached, the void breaks down. The voltage becomes zero immediately, but the supply voltage goes on increasing. Then, after some time, when the void regains its dielectric strength back, then what happens? Once again, the stress may be so that it may create another breakdown. So, this is the thing which happens. A series of breakdown may take place up to this point. Similar thing will occur in the negative half cycle also. So, ultimately, in the long run, carbon development of carbon particles due to heat generation inside the dielectric may be such that it may short circuit the core and the outer sheath, resulting in complete failure of the insulation of the cable and in general the cable. Now, so in the case of AC application, there is a chance of repeated Flashover, I should not say flashover, the correct term will be repeated discharge or repeated breakdown of the earth. But in the case of DC, there will be only one breakdown because in DC, the magnitude of the voltage is not changing, neither the DVDT increases. There may be one breakdown or one ionization of air bubble, but the voltage magnitude is held constant at that value. So the DVDT will not change. And as a result, in DC, there will be a single breakdown. Is the point clear?
Yes, sir.
Okay. Next, let us discuss bushings. Now, bushing, you must have seen, this is uh, an insulator. Bushing, I should say, this is made up of insulating material, looks like a pin type insulator or so. These bushings are used for taking the connections out or taking the connections into the high voltage equipments like transformers, circuit breakers, potential transformers, current transformers, etc. Now, oil field type of bushing is looks like this. Actually, you see, this is the flange to which it is connected to the equipment to which either connection is to be brought in or connection is to be taken out. And this is the channel through which oil is circulated, and this is the electrode through which connection is made. Now, this oil is circulated inside just to keep our temperature within limit. I mean, within limit, so that the bushing remains cool. Now, again, there are problems which I'll not discuss. We just go to the problem. Next, we shall discuss compound field bushing is not that important. It is synthetic resin bonded papers are there inside. But the thing which is important, that is condenser bushing. Now, this is stress distribution. You see, this is the electrode, and this is the place which is flange, which is connected to the body of the equipment, maybe transformer, circuit breaker, whatever. So the electric fields coming out from the live electrode will try to terminate on the ground electrode. Now, these are the distribution of electric field lines: 25%, 50%, 75%, etc. Now, actually, you see here the 25% field line, or these are basically, I should not say field line, they are equipotential line. 25% line is very close to the earth plate. So there is other lines, other like 10%, 15%, 5% will be almost touching the earth. In order to distribute the field lines or equipotential lines, you see condenser bushings are used. And in condenser bushing, what is done is aluminum or tin foils in the form of cylinders are introduced inside the uh, dielectric. This reduces the axial stress near the earth plate of the bushing, as shown in the figure. You see in the previous diagram, 25% equipotential line was very close to the earth flange or plate, but here, due to introduction of the aluminum or tin foils inside, actually the 20% equipotential line is raised much above the earth flange or earth plate. So this is the thing about the condenser bushing. I stop here today. If you have any question, you may ask me. Otherwise, I request you to go through this entire chapter, and if you have any question, any doubt, etc., to contact me. We shall arrange one or more classes.
Okay, sir.
Okay. Okay then.
Thank you, sir.
Thank you, sir. Thank you, sir.
Okay. Thank you very much.
Thank you, sir.
Hope we shall be able to meet physically in a class very quickly. Let us hope so.
Yes, sir.
Uh, I took your class Principles of Electrical Engineering in first year, na?
Yes, sir.
Yes, sir.
Which that is in the year 2018 or 19.
18, sir. Yes.